Hello students, this is Dr. Munir Omar with CS 371 Data Communication and Networks. Today we will be studying about the flow control and error control. These two are performed at the data link layer. This is our part first, and also we will resume the same topic in the next lecture. These are the main objectives for our today's lecture. By the end of this lecture and also the second part of this topic, the students would be able to understand the difference between the noiseless channel and noisy channel. The students would also be able to know about the need of flow and error control, which is performed at the data link layer, to understand the different approaches to flow control and error control, and also to know the different flow control techniques in the data link layer and their advantages and disadvantages. As I told you that this topic is divided into two parts, so here we have part number one in today's lecture. These are the contents for our today's lecture. First, we will look into the flow and error control. Then we have some types of protocols and we will look into those protocols. And actually we have two type of channels, the noiseless channel and the channel having noise. So we will look into the protocols that are used for noiseless channel as well as for the noisy channel. But in this lecture, our main concern is noiseless channel. So in noiseless channel, we have simplest protocol and then stop and wait protocol. We will study about all these. And also for the simplest protocol and stop and wait protocol, we have some algorithms. We will also look into those algorithms. In the data link layer, there is a sublayer known as data link control or DLC, which deals with procedures for communication between two adjacent nodes or node to node communication. And the most important function of this sublayer is the flow control and error control. It includes the framing, flow, and error control. The most important responsibilities of data link layer are the flow control and error control. There are many other functions performed by the data link layer. Among those, these two are very important, and in fact the data link layer is known for the flow control and the error control. And we if call these two control, these are known as data link control or DLC. Flow control refers to the set of procedures used to restrict the amount of data that the sender can send before waiting for acknowledgement. Actually, the flow control is about the sending and receiving of data. Data is sent and whether that is received or not. So this is done by the flow control. The error control in the data link layer is based on automatic repeat request ARQ, which is the retransmission of data. So if the data is not received at the receiving end, due to some reasons the data is not transmitted properly, so that data would not be acknowledged by the receiver, and for that purpose the error control will retransmit that data frame to the receiver by the sender again. The flow control tells the sender that how much data should be sent to the receiver so that it is not lost. Actually, it is about the adjustment of transmission rate or the speed of sending data. In data communication, flow control is the process of managing the data rate of data transmission between two nodes to prevent a fast sender from overcome to slow receiver. In most of the cases, it is possible that the speed of receiver is slower than sender, as we know that one device may get data from multiple senders. So in that case, the receiver or the node receiving data may get stuck and may not be able to receive all the data transmitted by the sender. Flow control mechanism makes the sender wait for an acknowledgement before sending the next data. So in the flow control, we have an acknowledgement mechanism which bounds the sender for transmission. So if the sender receives an acknowledgement, after that it sends next frame. The ACK stands for acknowledgement. So in this lecture, we will use ACK instead of acknowledgement. Any transmission from a receiving station to the transmitting station communicating that the transmitted data has been received without any error. So this ACK identifies that the transmitted data have been received by the receiver. So next is the error control. It is occurred at the data link layer and also at the transport layer. We have studied about the error correction and detection at the data link layer and also at the transport layer in our previous lectures. So error control is the mechanism for detecting and correcting the error occurred in data frames that are delivered from sender to the receiver, or the error control in the data link layer is a process of detecting and retransmitting the data which has been lost or corrupted during the transmission of data. Actually, our main concern here is the retransmission of data, that when the data should be retransmitted. As we know that the error can be a single bit error or burst error. We have already studied about these. So now the main concern here in this lecture is automatic repeat request, ARQ, also called automatic repeat query, in an error control protocol that automatically initiates a call to retransmit any data packet or frame after receiving incorrect data. So if the data is not transmitted properly due to some reason, the receiver did not get that frame or packet, so that packet would be retransmitted by the sender by using ARQ mechanism. So this comes under the error control, and this thing is performed by the data link layer. The flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for acknowledgement. Whenever an entity produces item and another entity consumes them, there should be a balance between production and consumption rates. In other words, we can say that we have two nodes, one is sender and the second one is receiver. So the speed of sender must match the speed of receiver. If the items produced faster than they are consumed, the consumer can be overwhelmed and may need to discard some items. We can say that if the sender is speedy and the receiver is a bit slower, then the receiver would not be able to capture all the data transmitted by the sender. The error control in the data link layer is based on the automatic repeat request, which is the retransmission of data. This automatic repeat request is denoted by ARQ. So, this is used for the repetition of data if needed. We have two types of channels. The first one is noiseless channel and the second one is noisy channel. So traditionally there are four protocols uh, being defined for data link layer to deal with flow and error control. The simplest protocol, stop and wait, then go back and selective repeat. Although the first two protocols are still used at data link layer and the last two have disappeared. So we therefore briefly discuss the first two protocols in this lecture, in which we need to understand some wired and wireless LANs. By noiseless channel, we mean that the channel is an ideal channel and there is no sort of corruption. So there would be no frames lost or duplicated, and all the data sent will be transmitted successfully. In the noiseless channel, we have two protocols, the simple and stop and wait. So the first protocol is the simplest protocol, which has no flow or error control. We assume that the receiver can immediately handle any frame it is received. In other words, the receiver can never be overwhelmed with incoming frames. So, here the network layer passes data to data link layer, and then ultimately the data frame are sent through physical layer and then medium. So at the receiving end, the same frames are received by the receiver with the same processing or receiving speed which was done by the sender. So there is no chance of any loss and no need of flow control or error control. Here, the data link layers of both the sender and the receiver provide transmission services for their network layers. This one and this one both are given services by these two data link layers. The data link layers use the services provided by the physical layers of both sender and receiver. Here, note one thing, the sender side cannot send a frame until its network layer has a data packet to send. Similarly, the receiver side cannot deliver a data packet to its network layer until a frame arrives. If the protocol is implemented as a procedure, we need to introduce the idea of events in the protocol. This algorithm shows the procedure at the sender site. The algorithm has an infinite loop which means that from 3 to 9 these all statements will be executed forever. The algorithm is an event driven one, which means that it sleeps at line 3 until an event wakes it up at line 4. There is a gap between these actions. When the event a request from the network layer occurs, line 6 though 8 are executed. The program then repeats the loop again and sleeps at line 3 until the next occurrence of the event. We have written pseudocode for the main process. We do not show any details for the modules get data, make frame, and send frame. We have many things for these commands or for these modules inside, but we are not going into the depth. Simply understand that get data takes a data packet from the network layer, make frame adds a header and delimiter flag to the data packet to make a frame, and send frame delivers the frame to the physical layer for transmission. Then we have another algorithm at the receiver side. This algorithm has the same format as of previous, which was for sender or sender side, except there is a bit difference, except that the direction of the frames and data are upward. The event here is the arrival of a data frame after the event occurs. The data link layer receives the frame from the physical layer using the receive frame. Extract the data from the frame using the extract data, and then delivers the data to the network layer by using deliver data. We have similar wait for event, which is used to sleep until the event occurs, and then the arrival of the frame from the physical layer. So this algorithm is used at the receiver side, and this is the part of the simplest protocol used for noiseless channel. This figure shows an example of communication using the simple protocol. It is quite simple. The sender sends a sequence of frames without even thinking about the receiver. To send 3 frames, 3 events occur at the sender side and 3 events at the receiver side. Note one thing, that the data frames are shown in tilted boxes. These are not straight, these are actually tilted. These are because of the time difference between the sending and receiving. So actually some time is consumed here, that's why these are not straight. Now we have stop and wait protocol. In previous protocol we did not mention or did not notice the speed of transmission and reception at both the ends. But here, that thing is also considered, or we can say that the speed of sender and receiver both are considered. The frames must be accepted by the receiver in the same manner these are transmitted by the sender. Normally, the receiver does not have enough storage space, especially it is receiving data from many sources. This may result in either the discarding of frames or denial of service. So, if the receiver is not capable to receive or to capture all the data transmitted by the sender, so in that case, the receiver must acknowledge the sender about its capability or situation. In simple words, the receiver will let understand the sender to adjust its speed of transmission according to the speed of reception by the receiver. Now, if we compare this figure with the previous one, which was for simplest, there is a bit difference. That is, here we have the ACK frame generated by the receiver towards the sender. Now, if we look into the simple protocol, there isn't any acknowledgement frame by the receiver. This is the algorithm for stop and wait protocol at the sender side. Here, two events can occur: a request from the network layer and an arrival notification from the physical layer. The response to these events must alternate. In other words, after a frame is sent, the algorithm must ignore another network layer request until that frame is acknowledged. Means that either this one will be executed or this one will be executed. Or in simple words, if data is sent, then that data must be acknowledged by the receiver. To bind the sending with the acknowledgement, we use here can send variable. Now, if this can send is true, then this would be executed. Means that get data, make frame, and send frame will be executed. At the end, can send will be made as false, so that it would wait for this function to make it true, and this function is bounded with the acknowledgement or the arrival of acknowledgement. So whenever the acknowledgement frame is received, this can send would be assigned true, would be assigned to the can send variable, and again the next frame would be transmitted. There are many procedures or many statements behind the receive frame and send frame, make frame, and get data. So we are actually uh, looking this algorithm at the top, at the broader level, and we are not considering the in-depth implementation. This algorithm is for the stop and wait protocol at receiver side. This algorithm is similar to the simple protocol algorithm at receiver side. Here we have one additional thing, that is send frame. So the rest of the things are same. Once all the data is received, the data is extracted and delivered to the network layer. After that, the acknowledgement is sent, or the sender is informed about the status of the reception by the receiver. So this send frame is an additional statement, or this is a sort of function. This is an additional in the receiver side algorithm for stop and wait protocol. In this figure, we have stop and wait protocol. It is also simple. The sender sends frame to receiver, and then the receiver acknowledges the reception of this frame. We can say that the receiver sends another frame to sender, and the type of that frame is ACK, or acknowledgement. So in this way, the frames are transmitted from the sender to receiver, and for each reception, the receiver also acknowledges the sender. Again, the frames, or these lines, are treated. These are because of the time difference between the sending and receiving. We have some drawbacks for the stop and wait protocol in the noiseless channel. First one is that after each frame sent, the host must wait for an acknowledgement. So this is inefficient use of bandwidth. Now, if we look into this figure, the sender sent a frame, so it must wait till this point, and this is actually the loss of bandwidth by both the sender and receiver. To improve efficiency, the acknowledgement should be sent after multiple frames. Now, in the figure, we have one acknowledgement per frame received, and this is quite awkward. It should be made smart that we must have multiple frames here, and for multiple frames we can use a single acknowledgement. So in this way, the bandwidth should be utilized. We have alternatives, that is the sliding window protocols. These are go back n and selective repeat. So we have AR. This ARQ stands for automatic repeat request. We will resume this topic in the next lecture by starting with the same stop and wait automatic repeat. We have studied stop and wait, but this one is for noiseless channel, and this one ARQ stop and wait would be a bit different. Then we have go back and ARQ and select repeat. We will study all these. So first we have noisy channels. We will study this. Then the stop and wait ARQ. This figure is a bit different than the stop and wait for noiseless channel. Here we have the difference between the structure of ACK frame. Also, the algorithms are different. Now here, if you look into this figure, this one is different. In the noiseless channel, we assumed that the channel is ideal. There is no droppage of packets, but here the channel is not perfect and some frames may drop. So here a frame is dropped and also an acknowledgement is dropped. So this is possible is in noiseless channel. So we are going to study all these in the next lecture. These slides are prepared from the Data Communication and Networking book, which is authored by Behrouz Ferozan. If you have any question, you can put your comments in the KCMS. Thank you.